With 30-2, we have to represent different sample spaces by probability and by odds. There's a slight difference with how we want to kind of represent these. Probability meaning more of a fraction or a ratio that specifically always compares to the total or the universe of the sample space. That is always going to be on the bottom of a fraction when we're talking about a universe in here. On the top, we would want the number of ways, the number of outcomes that are, what we're interested in. And just creating a small sample space here. Say a six-sided die. And we would want different probabilities. Now there are six different things. If I was to kind of represent a die, for example, and when I start asking what's the probability that you're going to roll a 2 on that die, this is theoretical probability, I would have to put it out of 6, where the number of outcomes that are interested to us, or at least what I'm asking for, favorable, successful outcomes, well, there's only one of those. That's the ratio. There's one that we want versus, all of the ones that we would not want. But out of 6 is the actual probability statement. Now, I'm a big fan of leaving it as the actual ratio that still is connected to the sample space. I mean, it says it's out of 6 in this form because there was a universe or a total of 6. Now, as you say, use this division and use this fraction, sure, you can get a decimal out of it. And what this is doing is it's giving us a decimal. I'll leave 3 decimals. I had to round a little bit. So it's more like an approximation of probability. And because what we're doing here is we're realistically now converting the sample space to be out of 1. All numbers are out of 1 in theory. We would never really write that 1, that we would just write the decimal. And that's a true probability in theory, because probabilities by their very nature are supposed to be between 0 and 1. And maybe that 0.167 kind of gives you a better gauge of what the chance is. One, most people don't really like fractions. So 1 out of 6. I mean, to me, this is about where we're at in the whole scheme of things. Between 0 and 1, we're at about 0.167. Now, if we were to physically convert this into maybe like a more user-friendly version for a lot of people really like percentages. And so as I multiply this by 100, I could write it as 16.7%. And all that's doing is now we're just changing it to say, well, the total is 100%. And it's 16.7 out of 100. We would never really write it out of 100%. That just seems ridiculous. We would just write it as a percentage. And they all more or less represent the same thing, but with my personal favorite as 1 over 6. Now, using the same sample space, we were supposed to also be able to do odds. Odds in my brain are more of a way of comparing, and for us to kind of figure out, what's more likely getting what you want versus what you don't want. Now, this is more of a side-by-side ratio. We're going to be analyzing the breakdown of the sample space. And so if I wanted to, for example, ask what are the odds, and a lot of our odds usually are in favor, where we do want the positive, what we're interested in, written as the starting part of this ratio, this comparison ratio. What are the odds in favor of rolling a 2 on this sample space in this die? Well, it was 1 out of 6, But as you look at the outcomes that were favorable versus all of the outcomes that are not, could create a ratio to say, well, there was only one outcome versus the 5 that we didn't want if we were looking for the odds of picking or rolling a 2. Now, what's kind of doing is it's like comparing two different probabilities. There's a 1 out of 6 chance of getting a 2. There's a 5 out of 6 chance of not getting a 2. But these are supposed to be comparing stuff, and comparing 6 versus 6 is very redundant. And so we're going to be efficient and only compare the outcomes 1 to 5. Now, this is not really a percentage. It's not used as 1 divided by 5 because 5 is not the total. 6 is the total. 1 to 5 adds up to 6 as it represents all 6 outcomes, but it is a breakdown of what we would want versus what we would not want. I could say the exact same statement, but if I said, what are the odds against getting a 2, I would be more negative. I would put what's not a 2 first, all 5 ways to kind of roll something other than a 2, the complement versus the 1. There are 2 different orders to these odds, but it's just a slightly different perspective on sample space. Now, also, when we start this probability business and the odds business, it is very, very effective to see the outcomes. I mean, if I rolled the die, I spent an extra bit of effort showing all 6 things. Now, this is beginning to become very, very critical if we start having multiple objects. I could say let's toss 3 coins, which is a fairly complex situation. According to the fundamental counting principle, there are 2 outcomes per the first coin, and then 2 outcomes for the second coin, and then 2 outcomes for the third coin, meaning that there will be now a total of 8, universe of 8. Any probability question I ask, out of 8. So if I ask what is the probability of getting, a 2 heads and 1 tail, this would be a kind of a challenging question because there's 8 possible things, and it might not be super convenient just to try and figure this out in our head. We want to draw this out. And one way to draw a sample space, it's more visible here, is to draw what we're calling a tree diagram, where you physically show for the first coin, these are the things that could happen. Those are the 2 outcomes that could happen. And then for the next coin, all of the combinations that are created. There's 2 outcomes in that next coin. Well, that's head and tails. But combine that with what you could have also got on the first point. There's more combinations of heads and tails. And now I would have to multiply this and expand this out one more time for the third coin, showing all the combinations yet again, all 2 outcomes for the third coin, meaning the head or the tail, and then all the different combinations create 8. Count them up with me. That is 1, 2, 3, 4, 5, 6, 7, 8 outcomes. And this is a very, very effective way of sorting it out, seeing every single path, seeing 8 things. Because when I start describing a probability, like what's the probability of getting 2 heads and 1 tail, I can then just go find them. There's this outcome called head, head, tail, but there's more. There's this other outcome called head, tail, head, which also meets that description. And there's this third outcome called tail, head, head, which still matches the description. And from just visual sample space, I would be able to take a reasonably challenging probability scenario and say it is 3 out of 8. Or I could have reworded this question and I could have asked, what are the odds in favor of getting 2 heads and 1 tail? Where now, because I have that sample space, I would be able to say, well, pretty clearly, well, there's 3 ways that work, and 1, 2, 3, 4, 5 ways that don't, which adds up to 8, but we can then write odds. Now, if there's not so many items, because there was 3 coins, I really did have to draw a tree diagram here. But if we say now pare it down to just 2 objects, for example, if I had 2 4-sided die, what would this could look like? What is the probability of rolling a, oh, let's just do a pair. Pair meaning the same die twice, like a pair of 1s or a pair of 2s, for example. What is the probability of this? Now, where we would, for where I would like to start is, first of all, pull out the fundamental counting principle. There are 4 outcomes on the first die, and then 4 outcomes on that second die, meaning the probability is going to be out of 16 total. And one way to organize this very quickly, especially when there's just 2 items, is a table where I can represent all 4 outcomes, 1, 2, 3, 4, on one side of the table, and I can represent the other object and all of its outcomes on a second side of this table. But the actual really good part of this sample space comes when you multiply these together and you get this inside space. Make it a little bit bigger. And we get all of this multiplication space. And that is where the goods are. That is where all 16 outcomes exist. And let me just even break that up into 16 perfectly spaced out, perfectly equal sections on my sample space. Where now I could use this, another visual aid, to answer this question. What is the chance of getting a pair? Well, here's one, here's another one, here's another one, and here's another one. Those are the rolls known as the 1-1, or the 2-2, or the 3-3, or the 4-4. And I can use this and I can say, well, there are 4 things that worked out of the total. Out of all 16 outcomes, only 4 of them were rolling a pair. 4 out of 16. That's reducible. I don't really see the merit in reducing the fraction since there's 16 outcomes. 1 out of 4 is the same thing. It's still fine. It's great. So is using a decimal. So is using a percentage. They are absolutely all a way of measuring chance, which is a ratio compared to the total. Hopefully this has helped you get started in probability.